right, so welcome to today's lecture. We're looking at inequalities tonight, and we're going to start with looking at linear inequalities, and then from there we'll proceed to rational. And after rational, that's when we look at the quadratic inequalities. And yeah, we'll look at quadratic inequalities. Okay, so let's quickly begin to solve. Okay, so before we even begin solving these inequalities, first have to understand that solutions of inequalities are usually intervals. Yeah, so most of the solutions of inequalities are intervals. There are three types of intervals that you need to know. Yeah, so we talked about intervals the time we were discussing sets. We know to say when you have this kind of a bracket, it means that if you have, let's say for instance, 2, 3, means that we're talking about numbers between 2 and 3, but 2 and 3 are not included in the set. When we talk about these square brackets, 2, 3, yeah, so this implies that 2 and 3 are part of the set. Then when you have this, we're talking about numbers between 2 and 3, and 3 is also supposed to be part of the set, but 2 is not going to be part of the set. Then when you have something like this, 2, 3, this implies that 2 is part of the set, and then 3 is not part of the set. And then the other thing that we need to look at is that every time you have either positive infinity or negative infinity, let me say negative infinity or positive infinity, these, they always carry an open bracket. So these kinds of brackets are called closed brackets. Then these kind of brackets are called open brackets. Okay. Yeah. Then for the infinite symbols, they always carry open brackets. So if you have maybe negative infinity, 3, here they're supposed to be open, and then on 3, to depend if 3 is part of the set, you're going to have closed brackets, and then if it's not part of the set, you're going to have open brackets. So you have to understand all these things. So intervals are normally, rather inequalities have solutions which are represented in intervals in most cases. Okay, so this is what I'm just talking about. Okay, so this is what I was just talking about. This is an open bracket, even that one, then that one. So open brackets can be represented using less or, using greater than symbol or less than symbol there. Yeah, so that's what this means. So if we have, for instance, numbers from negative infinity up to 2, like this, if at all we have open brackets on both ends, this implies that we are talking about numbers that are less than 2. So x is less than 2. So this and that are simply just the same. And if you have 2, positive infinity, this one is just the same as x. X is greater than 2. But if we have 2, okay, let me say, okay, 2, close bracket at 2, infinity, like this. This implies that 2 is part of the set. Hence, we say x is greater or equal to 2 because of this type of a bracket. That's what that means. All right. So half open interval means that it has one side open, the other side closed. Then we also have closed intervals, which I've already talked about, like this one. All right, so the other thing that the other thing that you need to understand about inequalities is just the rules of equalities that we talked about. The rules of equality that we talked about. So if you have, for instance, A is greater than B, if you are going to add C this side, it means that you're also supposed to add C this side. That's that's what it means when you talk about an equation. So the same equality equations or equality rules that we learned, they also apply on inequalities. So if you have A is greater than B, if we multiply this by C, it means that even on the right-hand side, we also have to multiply B by C. Yeah, so this is what it means. Yeah, so it's something that is straightforward. Yeah. All right, so let's look at this example here. The question is solve 3x minus 4, which is greater than 8, and graph the solution. So we have 3x minus 4 greater than 8. So you take this -4 to the other side of the equal sign, you're going to have 3x is greater than 8 plus 4. So we're going to have 3x is greater than 8 plus 4, the answer is 12. And when we divide by 3 on both sides, we're going to have 3 this side over 3, and the value of x will simply just be greater than 4. So this one can also be represented in an inequality form as, rather in an interval form as x is equal to, since we're saying x is greater than 4, meaning we're going to start from 4. This is 4, and then it's going to be open at 4 because it's not greater or equal to. So we write an open bracket there at 4. Okay. So say it's open at 4, and then we say comma, positive infinity. And then on the infinite symbol, there's always an open bracket. You don't have to put a closed bracket there. Okay, so this is the solution for this interval that we have. Let's quickly look at another question. There's also this question, which is -5, open brackets, we have x minus 1 less or equal to 10. Okay, I forgot one thing, graphing the solution. Okay, I'll start from the second one. Okay, let me just do the first one as well. So we have the solution, which is, we had the solution which was just, the solution for this one was x greater than 4. So if you are to put this on the x or y plane, you have 0, and then this is an x or y plane. You have x there, then you have y there. And we're saying x is greater than 4. Yeah, so we're going to draw a line on the x or y plane, which is just x is equal to 4. So x is equal to 4. We're going to have 1, 2, 3, 4. So 4 will be there. So the line, oh, rather x is equal to 4. We're going to have 1, 2, 3, 4. So 4 is going to be there. So note this one here. We're in the x-axis. So we're going to draw this line there. So when we draw a straight line on 4, this is a line x is equal to 4. But to draw this one, x is greater than 4. Yeah, so since if this was x is greater or equal to 4, we would have drawn a bold line like this. Now, since we have a greater than symbol without a greater, without an equal sign symbol, means that we're going to draw a dotted line instead of a bold line. And then the question is, I mean, the solution is greater. So meaning the wanted region that we want is this part here, this part going this side. That is the range that is carrying x greater than 4. Hence, to shade this, we're going to shade the unwanted region. So shading the unwanted region, meaning we're going to shade this part of the line. We're going to do this. That is how you represent the graph of inequalities. So it's dotted because it's just greater than symbol. So if we have, for instance, the second one that we're going to have, we're going to draw a bold line because there is less or equal to symbol there. So we're going to draw a bold line, not a dotted line. This one I've drawn a dotted line because there is just greater than symbol. There's no equal sign symbol there. Okay. So for the second one, we have -5 open brackets x minus 1, then less or equal to 10. So solving this, we're going to get -5 times x. This will be -5x. -5 times -1 will get +5, then less or equal to 10. So we pair the like terms. We're going to have -5x is less or equal to, we take this 5 to the other side of the equal sign. We're going to have 10 minus 5. So we're going to have -5x less or equal to 5 minus 10 minus 5. This will give us 10 minus 5. This will give us 5. So once you have that, you now divide everything by -5. So -5x less or equal to 5. So when you divide by -5, divide by -5, the sign is going to change. Yeah, so when you divide by -5, the sign is simply just going to change. So this x will now therefore be equal to x greater or equal to -1. So when you're dealing with inequalities, every time you divide by a negative number, you have to change the sign in between. That's what we normally do. And then when it comes to sketching, this one is also straightforward. We're sketching this on the x or y plane. So you do this, you have 0 there, and then you have x, you have y. And then the other thing that you are going to have there is simply just we'll move 1 unit in the negative of the x-axis. So move 1 unit in the negative of the x-axis, which is just going to be somewhere there. So -1 will be somewhere there. So -1 is there. And since we have greater or equal to symbol, it means that we're going to draw a bold line, not a dotted line. So let me just write the -1 properly. So the negative is here and the 1 is there. And then we're saying the region that is wanted in this case is simply just numbers greater than -1, which are just numbers which are this side, the range which is going this side. So numbers going this side is the wanted region. So we're going to shade the unwanted region. So shading the unwanted region, you shade this part, this side. And in case the question does not specify whether you are shading the unwanted or wanted region, what you simply have to do is you can make your own key. Yeah, you can make your own key and just say, this part, you can say this is the unwanted region. Because I've seen some books, in some books they show they shade the wanted region, and in other books they shade the unwanted region. So you have to indicate that. Yeah. So let's quickly move on to the next question. Okay, so we have this question here. So for this question, what you can just do to solve such a question is, because we have this part here, we also have the other part, which is that side. So what you can just do to solve this question is you divide this question into 2. Okay, Linda, you have a question? You can ask, please. You can unmute yourself and ask.
Hello?
Yes, I'm getting you.
Yes, I'm saying on the shading part, that's where I'm behind. Kindly repeat yourself.
Okay, so on the shading part, I was saying,
yes.
If, for instance, the solution that we got here was x is greater or equal to -1. So when you are drawing the xy plane, you have something like this, and then you put your -1 there. So if you have this kind of a symbol, it means that you are going to draw a bold line. And then if you have just greater than or just less than, if you have greater or equal to or less or equal to, you draw a bold line. But if you only have less than symbol or greater than symbol, you draw a dotted line. That's one of the most important things that you need to know. Then apart from that, since this one here is greater or equal to, it means that we're drawing a bold line at -1. So when we draw a bold line at -1, you simply have to shade the unwanted region. So the unwanted region, the wanted region is this one, because this is the solution set for this expression. So the solution set is x greater than -1, meaning we're talking about numbers that are from -1 going this side. So from -1 going this side, these are the numbers that we need in our solution set. Hence, when shading that, if we have been told to shade the unwanted region, meaning we'll shade this side. So you indicate to say this is the unwanted region. But if the lecturer has specified to say shade the unwanted region, you don't have to indicate. Yeah. All right. So this is what it means to shade. That is how you shade. So you only draw a dotted line when you have such symbols. And then when you have these symbols, you draw a bold line. All right, so let's quickly move on. Okay, so we have this last question here. So this question is also straightforward. So you have this first part here. So I'm going to solve this first part. Then after that, we'll come and solve this part. And then we find two solutions. So I'm going to get this part. So the answer, I mean, when I get that part, I'm going to have -6 less -2x minus 1. So I'll take everything. I'll take, I'll put the like terms together. So I'm going to have -6 plus 1 less -2x. Then -6 plus 1, this is simply just -5 less -2x. When I divide by -2, divide by -2, I'm going to get 5/2. When we divide by a negative number, the symbol changes there. So we'll have x this side. And then I want to switch this. I want x to be on the left and then the number to be on the right, meaning even the symbol there will switch. So I'm going to have x is less than 5/2. Okay, so that's what you have to do. Then sketching this is also straightforward. Oh, before we do that, let us solve the other part. So the other part is simply just this one, this part here. So this part is simply just -2x minus 1 less 6. So we take this -1 to the other side of the equal sign. So we're going to have -2x less 6 plus 1. So -2x less 6 plus 1, this is just 7. When we divide by -2, divide by -2, the answer will simply just be x greater than -7/2. Yeah, so these are the two solution sets that we have. So now let's go and sketch this. So sketching this, we have x less than 5/2. So my approximation will be that 5/2 is there. And then x greater than -7/2. X greater than -7. So my -7/2, I'll just put it there. So because there's no equal sign on both, I'm going to draw dotted lines on both. So when I draw the dotted lines, I'm going to shade the unwanted region. So this one is saying x less than 5/2. So x less than 5/2, it means that the wanted region is this part, which is less than 5/2. This other part is greater than 5/2, meaning it's the unwanted. So I'm going to shade the unwanted region, which is just this part. And then this one was saying x greater than -7/2. So x greater than -7/2 is simply just this part here is the one that is greater than -7/2, meaning the unwanted region is this one that I'm shading. So from this sketch or from this shading, you can even get the solution set in short. So the solution set for this one, we can say x is greater than, rather x is equal to numbers between -7/2 and numbers between -7/2. We're talking about these numbers in between here, -7/2 and 5/2 and 5/2. So because we have dotted lines on both ends, meaning we're going to have this kind of brackets. So this is the solution set, or if you want, you can write it in set builder notation, which can just be written as x such that you have -7/2 less x less 5/2. So this one, use this kind of brackets. So this one is exactly the same as that. Okay, so I don't know if you have any questions before we can proceed to quadratic inequalities. Okay, so let's quickly move on. So quadratic inequalities, these are also straightforward. The most important thing to do is just solving the quadratic equation. So if you don't know how to solve quadratic equations, you find problems in doing such questions. All right, so let's quickly do this one. So what we'll do first, we'll find the critical points. And how do we find those critical points? We solve this quadratic equation. So we say x squared plus 2x minus 8 is equal to 0. Then from there, we solve the quadratic equation. Find the product. The product is simply just the coefficient of x squared times the constant. 1 times -8 is simply just -8. Then the sum is 2. Then we find the factors. The factors are simply just numbers which are such that if we multiply them, they'll give us -8. If we add them, they'll give us 2. And these two numbers are simply just 4 and -2. So when we multiply -2 and 4, we're going to get -8. Then when you add -2 and 4, we'll get +2. So we plug them in there. So we're going to have x squared, and then x squared minus 2x plus 4x, then minus 8 is equal to 0. So we factorize, we have x, and then x minus 2 there. Then we have +4, x minus 2 there. So x minus 2 is common. Then we have x plus 4, it's also common, which is equal to 0. So we equate x minus 2 to 0 and x plus 4 to 0. So x minus 2 is equal to 0 and x plus 4 is equal to 0. So from there, we can find the critical points. So when we find the answer here, the value of x is simply just be equal to 2. Then here, the value of x will simply just be equal to -4. So these are not the final answers. We are going to draw the number line. We're going to put our critical points. So these are called critical points. So we put our critical points on the number line. We have -4 there. Then we have +2 there. Then we have this region from -4 going this side. This region is simply just x less than -4. And then the region between -4 and 2 are simply just -4 less x less 2. And then the region that is above or greater than 2, we say x greater than 2. So now let us get any number that is less than -4. We can even get -5. So when we get -5, we're going to test this -5 in this expression here. In this expression, that is where we're going to test -5. So I'm going to write this expression on top, which is just x minus 2. We put x minus 2 there, and then we also put x plus 4 there. And then we say, we use this symbol which is there, which is greater than 0. Okay, so from there, we can test these numbers. Let us get a number that is less than -4, meaning we're testing this region this side. So a number that is less than -4 is simply just, we can get -5. So when we put -5 where there's x here, -5 minus 2, this is going to give us -7. So -7, I'm not going to write -7, but I'm just going to write the symbol there, which is negative. And then when you put -5 there, we're going to get -5 plus 4, which is also going to be -1. So I'll also write a negative, not a -1 that I've found. I'll just write the symbol negative. So negative times negative, the answer will be positive. So we can now ask ourselves to say, is a positive number greater than 0? The positive number is greater than 0, then this region is part of our solution. So the positive number, is it greater than 0? Yes, so meaning it's part of our solution. Let's get any number that is between -4 and 2. So we're testing this region now. -4 and 2, we can even get a 0. So when we put 0 there, we're going to have 0 minus 2, the answer will be a negative, and then it will be a -2. So I'll just write negative there. So when you put a 0 there again, we're going to have 0 plus 4, that will just give us +4. So +4, I'm not going to write +4, I'll just write positive there. So positive times negative, the answer is negative. So is a negative number greater than 0? The answer is no. So this region has been rejected. Let us also test this region this side. We get any number that is greater than 2. So when you put 2 there, we can't put 2 rather. Let's get any number that is greater than 2. We get 3. When you put 3 there, we're going to have 3 minus 2. The answer is 1, which is a positive 1. So we're going to write a +1 there. And then multiplied by, we put a 3 there. We're going to have 3 plus 4. The answer is 7. So that is a +7. So we put a positive there. Positive times positive, the answer is positive. So is a positive number greater than 0? The answer is yes. So the two regions that we want, or that they want us to find in this question, are simply just x less than -4 and x greater than 2. So these are the two solution sets. So if you want, you can write them in set builder notation, rather in interval notation, as x is equal to numbers that are less than -4. You can say from -infinity up to -4. And then we say union, we're combining these two sets. And then we say union, numbers that are greater than 2, we can write them as 2, positive infinity. So these are the solutions that are needed. All right, let's quickly move on to the next question. Do you have any questions before we proceed? All right, so this one is straightforward. Okay, so this one is also a quadratic equation. Yes, Raphael, what's your question?
So I'm still behind.
Okay, we still have another quadratic equation. Let's solve this one.
Okay, I appreciate, sir.
Okay, so even this one, the first thing that you have to do is to solve the quadratic equation. So when you solve this quadratic equation, you have to find the product, the sum, and the factors. So the product is simply just found by multiplying 2 and -6 there. So 2 times -6, the answer is -12. The sum is found just by getting the coefficient of x, which is just 1. The factors are going to be found by getting this product, and then we find two numbers that if multiplied, if these numbers are multiplied, the answer will simply just be -12. And then when you add these two numbers, the answer is simply just going to be 1. So these numbers are simply -3 and 4. So when you add -3 and 4, you're going to get +1. when you multiply -3 and 4, you're going to get -4. So we replace them in the function there. So I'm going to say 2x squared minus 3x positive 4x, then we say -6. This one I'm going to say is equal to 0. We want to find first critical points. So we factorize the common factor on the first two terms there is simply just x. So x into 2x, we're going to get 2x, then minus x into 3x, this will be 3. And then we say here we have 2 is also common. So 2 is common there. 2 into 4x, this will be 2x. 2 into 6, that will be 3, is equal to 0. So make sure that this part and that part is the same. If they are different, it means that you have made a mistake somewhere. So we can write this 2x minus 3, and then we have this x plus 2 is equal to 0. So the critical points we have, if you simplify this, or let me equate them to zeros first, is equal to 0. Then we have x plus 2 is equal to 0. So when you equate this to 0 and simplify it, the value of x will simply just be 3/2. When you equate this to 0, the value of x is simply just going to be x is equal to -2. All right, so from there, we can now, these are critical points. So we have found the critical points. We can now take them on the number line. So -2 will be written there. Then we have +3/2 there. So numbers that are greater than +3/2 are going to say x greater than 3/2. And then numbers that are between here will just say -2 less x less 3/2. But because there's this less or equal to, so meaning even the symbols there are going to say less, greater or equal to, even there less or equal to, less or equal to. So numbers that are greater, rather that are less than -2, say x less or equal to -2. So now we get this expression there. We write it on top. And then we use this symbol there. We put it there. So let us now start testing the points. So we get this region this side, meaning numbers that are less than -2, you can get -3. So if we put -3 there, where there's x, we're going to have 2 times -3. 2 times -3 is going to give us -6. -6 minus 3, we're going to get -9. So -9 is a negative number. I'll just write the negative there. And then I'll put the same -3 that I had put there on x again there. So -3 plus 2, the answer is -1. So -1 is a negative number as well. So just write a negative. So negative times negative, the answer is positive. So is a positive number less than or equal to 0? The answer is no. So this region is rejected. So let us go on the second region. We get any number that is between -2 and 3/2. So we can also get a 0. 0 is between -2 and 3/2. If you want, you can get -1. Yeah, if you want, you can get 1. 1 is also between these two numbers. Okay, so let us get any number. So I like using 0 if there's a negative and a positive number. So if we get a 0, we replace it there. We're going to have 0 minus 3. That will be a negative number, -3. And then when you put 0 there, 0 plus 2, the answer will be a positive number, which is positive. So positive times negative, the answer is negative. So is a negative number less or equal to 0? The answer is yes. So this region is part of our solution. Let us also test this region this side, numbers that are greater than 3/2. So numbers that are greater than 3/2, 3/2 is simply just the same as 1.5. So numbers that are greater than 1.5, we can even get 2, or if not 2, we can get 3. Or if you want, we can get 4, any number that is greater than 1.5. So we can even get 3. So when you put 3 there, we're going to have 2 times 3, that's 6. 6 minus 3, the answer is 6 minus 3, the answer is +3. So I'm going to write a positive number there, a positive symbol. So we also put the same 3 there. 3 plus 2, the answer is positive 5. So positive 5, I'm just going to write a positive. So positive and positive, the answer is positive there. So this positive, is it less or equal to 0? The answer is no. So a positive number is always greater than 0. So it's not less than 0. So what do? You cross out this region. So it's not also accepted. Hence, what we do is, since it's not accepted, what you now do is you get the region that has been accepted there. So the region that has been accepted is simply just from -2 to 3/2. So of course, since the symbol that is there is less or equal to, meaning you also have to be including that my equal to sign there. So from there, if you want, you can write this in an interval notation, which can also just be written as x is equal to numbers between -2 and 3/2. So numbers between -2 and 3/2. But because we have less or equal to symbol there, it means what? It means that we're using the closed brackets on both ends. All right, so this is exactly what you're supposed to do. Do we have any questions?
No.
Okay.
Kindly repeat yourself on the number line. On how to solve the quadratic, it's clear, I'm clear. Now, how to, on the number line there, sir.
Okay, so on the number line, the
I'm
most
still
important
behind.
thing, yeah, so the most important part that you need to get on the number line is this part here. It's this part. So once you get this part, you write it there. When you write it there, make sure that you also get the symbol which you've been given there in the question. That is the one that I've put there. Okay, Mary, you can also ask a question so that I just explain everything at once.
Okay, I just want to find out when solving the equation, can't you use that other one, the quadratic formula?
You can use any method.
Hello?
Yes, you can use any method as long as you get the correct answers. Any method is okay. All right.
Okay.
Yes.
Thank you.
So after getting this equation there, you also put the symbol there. Then you start testing the regions. So you know that if you put the number line there, this side, you are talking about numbers that are less than -2. And then in between here, you are talking about numbers between -2 and 3/2. And then this side, this other part, you are talking about numbers that are greater than 3/2. So when testing these, you just get any number. If I start with this region this side, if I start with this region this side, means that I'm getting any number. You can just get any number, but as long as it's less than -2. Then when you're testing you get that number and then you put it where there's x there. When you put it, in short, you just solve this equation. The answer that you are getting, if it's a negative number, you just write a negative symbol there. Don't write that negative number. If you want, you can also be writing numbers. But whenever you find that answer there, try to check if that answer is less than or greater than 0. Yeah, so in short, you should be solving the equation. In short, if you don't want to understand the principle of just writing the symbols, the negative and the negative symbol, the negative and the